This is a full-scale project called Tracking and Control of Articulated Machines Through Remote Sensing, or for short, TrackMac. We need to have some abbreviations to make these things easier to talk about. And this project started in 2017 and was supposed to finish last year in August, but has been extended several times now. And that is because we have not been able to collect some of the data that we wanted to collect at our partners. So the partners are Epiroc and Zingruvan. And thanks to Corona, it has been really difficult to go down in the mine and collect data. So we've had to extend this project several times, and there has not actually been that much to report in the last year, but I'll go over the major things that we have been doing. So what's the project about? Similar to the previous project I talked about, we are looking into this sort of machines that do drilling of blast holes or drilling of holes in the ceiling for support. Here's an example from the mine, from actually me pretending that I'm driving it, but just hacking on a laptop somewhere inside. So we have we have a machine with booms, and it is drilling holes. The problem is that sometimes some of these cables connecting the machine get damaged. In that case, they need to be repaired. In particular, it is a big problem for automated systems, which simply cannot operate if one of these cables here is broken. So it is possible to move the machine manually maybe, but in an automated fashion, it's very difficult. And that is because we do not know how this machine is actually configured without having access to the data from different sensors connected to the machine. So the job in our project here was to use visual sensors like the ones mounted here on the machine to try to estimate the state of the machine. And I'll give you an example from some of the results we did. We got this is a slightly earlier work where we put the machine inside a hangar. And what we do is we move to different configurations, and for each of the joints of the machine, we try to estimate how it moves. The red and the green here are the what we get from the sensors and what we can estimate just by looking at the scene. Okay, so we have already an approach which works quite well. And we've had that for the last two years already. What we needed to do was we wanted to validate this approach on real data from the mine, which was very difficult to come by. So instead, what we have been doing is we have been trying to improve generalizability of our neural networks by comparing under different conditions. For example, when there's noise in the image, when there's different lighting conditions, and we just submitted a paper detailing this approach of generalizing to different data. So here you can see some of the examples from the data that we used in two different locations inside this hangar, and some data from outdoors and some data from so we have some data sets, but at the moment what we're doing is we're trying to finalize the data collection so that we can evaluate our methods in these kind of conditions. Right, so the next steps is that we're actually just right now preparing a data setup that's going to be mounted in Zingruvan, stay there for a couple of weeks, and we are writing the final project report and hoping to finalize this by the end of the year latest. Thank you.
All right, thank you very much. And another very interesting and valuable project. So yeah, we talked about that during the break, that in our portfolio right now we have such amount of very, very interesting and valuable projects. So we couldn't be more happy. So thank you again, Todor. The next presenter will be Sohail Manzoor from Lulu University of Technology. And we can see your presentation. We can see you. Now we can see you as well. Hi.
Hi. Hello everyone. My name is Sohail Manzoor, and I'm a PhD student in mining and rock engineering at Lulu University of Technology. I'm working with Anna Gustafsson, who is project leader for this project on improved resource efficiency through dynamic loading control, and it's a continuation project. And other project partners include LKB and Agio Systems and Competency Scandinavia. Okay, this project is intended to implement the draw control strategy that was developed in the previous research project, improved resource efficiency through dynamic loading control. And the goal of this project is to improve the loading of blasted material from sublevel caving rings and ultimately improve the resource efficiency of sublevel caving mines. Basically, when we start loading from a new ring, we start with a negative profit. That means capital cost of drilling, blasting, and other related costs for opening a new ring. And with every bucket loaded of ore, we start getting back money and we start making profit. And after loading for some time, the ore starts to finish and the waste material starts coming in greater quantity. And we start losing money instead of making profit. Normally loading is continued for a little while in a hope of getting ore again and getting maybe profit again. However, it cannot happen and we can keep on losing money as well. So this developed model or strategy called the dynamic loading draw control strategy helps to make a wiser decision by putting a decision box and setting limits on how much should be loaded when losing money before it's too late in terms of losing too much money or the valuable ore in place. Because once we stop loading from a ring and move to the next ring, we cannot mine out the leftover ore on the same level. And the size of this box is selected based on a probability model that use the historical data of the mine. And all this work is documented in Gurmeet Shekhar's doctoral thesis. So in this project, a new graphical user interface was developed and it was installed in LKB's Kiruna Mines loading control system. And a test was carried out for a quarter of an year in 2020. And this image shows how it looks like for the decision maker during the loading of the ore for a certain ring. And this is the view from the production planning's office where they can see what's going on.
So
the test results show.
Okay, so 8 is not. It is not possible. Then
I
next
think
day
we hear you as well.
October, after Friday, which day?
The test results showed an increase of 300 ton in pellet production for quarter of the year, and on the same time there were lesser rings mined in that quarter as compared to the previous quarters, and that resulted in the overall efficiency of the mine in terms of resources as well as production. So there were more revenue and less rings mined out in that quarter. Final steps of the project include the installation of this new loading control system on all of the loading machines, and afterwards the model calibration based on the data collected from the machines. Thank you so much for your attention. It was my pleasure to present on this platform.
Thank you so much for us to have this presentation as well. And of course, we shall have ore coming up from the mines, not waste or rock with not enough from it. So thank you very much. And interesting to hear that you will probably then put these kind of equipment on so many hilers now. So very well done.
Thank you.
All right, and next presenter and the last at this theme is Karl Westerlund from Swedish Geological AB. And Kalle, I can see you and you are visible here. Can we hear you as well?
I am alive and kicking.
Alive and kicking, thank you.
Just try to upload my presentation here.
Yeah.
Doesn't work that well. I guess it's the arrow up button there.
Yeah, do you have it on your screen behind on your desktop? It seems to be the best way to do it.
You can't see this, I'm sure. Let's try again.
Yeah.
Okay. Share content.
Yeah, for most people, is that the window, not the screen, which do the best job. But I believe that you need to have your presentation open.
Yeah, it is open in the background, yeah.
Okay, so if you put share screen there, and if you not go to the desktop, as you go to the window, you should see one of your windows should be your presentation.
Yeah, it's just showing away. I'm sharing.
Do you have multiple screens in front of you?
No.
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 But then, Kalle, I think we do like this.
Nowadays, probably something, but could have something to do with that. That's a bit irritating. There's nothing else really I can push.
Can we do like this? You will give us, I suggest you give us the presentation where you are, because you know so much about your area, of course, and then we can, if you like, put on your presentation at our homepage afterwards.
Yeah,
we can have a link with that.
I'll just talk you through it. Yeah, we'll see if I can make some sense of it. Anyway, without the pics, I'm very sorry about that. Must have been upgraded the OSI the other day, so it could have something to do with that. Anyway, so remote mapper. My name is Karl Westerlund. I'm with Swedish Geological AB, and we've implemented this project together with Torkild Rasmus and Tobias Bauer at Lulu Technical University. It's called a high-resolution magnetic surveying using UAV, and it's a specific model called the remote mapper. And the remote mapper, it's a fixed-wing UAV. It's purpose-built for high-resolution magnetic surveys, and it's been used extensively in Southern Africa and also to a much lesser extent up in the Canadian Arctic. And the purpose of this pilot project was to test the remote mapper in the Swedish operational environment and assess things like climate, terrain, logistics, technical issues, and not the least permitting and administration. And the ultimate goal was to be able to provide the exploration and mining sector with a low-cost option for regional high-resolution magnetic surveys. And the project ended like last week or something like that. And basically, in short, we've covered about 36 square kilometers with this with remote mapper, flying with a line spacing of 25 meters and at 45 meters elevation. We wanted to cover quite a bit more, but we were cut short by COVID-19 in March last year when we did the most of the field work. So about the data, Torkild Rasmussen at LTU, he's been in charge of data processing and assessment, and in short, the data is of very high quality, high resolution, and above all, it has a very low noise level. So and it's low to the extent that you don't really need any post-processing of the data, which is extremely, say, good, because you don't lose any data quality in that way. And yeah, I was about to show you a couple of examples here. Basically, you can see it's a huge difference, of course, when you compare to the geological surveys, regional airborne data, mainly because that's flown with a much wider line spacing. Also interesting, it's the resolution is with the remote mapper is comparable, say, well, almost comparable with that of ground mag surveys. And I should say also with the added benefit that with the remote mapper, you will more truly kind of reflect magnetic continuities and discontinuities in the ground, simply because you would have a much denser data set, and there's less need for interpolation between data points. Because when you do walk mag, for example, you have quite often 100 meters between the lines, and you sample every 20 meters or something like that. Because of the high resolution of the data, you know, you can extract very subtle data features. So you can do geological interpretations at a very high detail, and that work has been started also by Tobias Bauer up at LTU. Yeah, then in terms of course, the project we've learned a lot with regards to operational requirements, limitations, and costs, and all this has been fed into a business plan. We were hoping for that we could provide this kind of service, you know, would be an order of magnitude lower the cost compared to conventional high-resolution surveys with manned helicopters and manned aircraft. That's not going to happen. It's still going to be significantly lower the cost compared to those techniques. And of course, interesting also is that you can, I mean, you can use it in certain circumstances as instead of ground mag surveys, because you can cover, you know, quite a large area in a very short time with remote mapper areas.
Karl, 1 minute.
Yeah, thank you. Right, so now the one key issue, the one really main issue with this, looking into the future, and that is that the permitting rules changed in January this year. They're now aligned with the EU rules, and you know, those it's very technically and administratively demanding to get across the hurdle there to get a permit with the new rules. And we are not there. With old rules, we would have been able to provide the services now, but now this is hampering the whole thing. So we have the technical capabilities, but we can't implement surveys at the moment because of that. So just looking into the future, as I said, the project has ended. But research and MSc studies using the data we've collected within the project, they are continuing after the project. And for us at SGAB, we need to sit down and think hard about how and if we can, just assess the possibility for a continuation in the future under the new permitting rules. Yeah, that's about it.
Yeah, thank you, Karl, and thank you for holding this presentation, even if we couldn't see your screen.
Yeah, you can just upload it, and everybody can go in there and see some nice pics.
That's perfect. And of course, it's a real struggle when you do your best on a project and you take the steps you thought was needed, and then of course now with a struggle with the permission for doing that kind of operation you thought you could do, that changed the whole playground for you. I know that's a hard thing, of course, but maybe something good can come up from that as well, and you can adapt in a way that you can actually work with those techniques, because it is sustainable, of course, and it seems to have very good quality and bang for the buck, sort of. Yeah, thank you. All right, this